Good morning. Hi, this is Mike Ryan. I'm the Director of Sales and Marketing at TXRX. Welcome to our webinar series. This webinar, which is about Land Mobile Radio Receive Infrastructure, is our 8th one this year. The webinar will be 45 minutes. The presentation itself is about a half hour, and then we will use the remaining time for Q&A. You will be muted, so please enter your questions in the question box, and we will address those at the end of the presentation. Now, I would like to introduce our presenter, Jason Wesolowski. Jason is a mechanical engineer and our quality manager. And also on the call is Jim Grotke, one of our applications engineers, who design our RF conditioning solutions. Jason, please take it away. Thank you.
Good morning, everyone. My name is Jason Wesolowski. As Mike mentioned, I'm the quality engineer here at TXRX Systems. And today we're going to be talking about the receive infrastructure for your land mobile radio system. So let's get right into this. The presentation today, we're going to go through 4 parts. The first is some basic building blocks of your land mobile radio system, and in particular, the receive portion of that system. After that, we're going to talk about some tower top amplifiers, then receive multicouplers, and then finally some receive system design considerations. So to start off with, this is your typical land mobile radio system. You start off and end with your subscribers. Those are usually some sort of public safety, or they might be workers at a factory or a warehouse facility that you've got. Either way, these are people that are out in the real world with handheld radios. They talk up to the RX antenna on your tower. That then passes the information to a tower top amplifier. That amplifier pushes the signal back down to the control unit, and finally to your radio at the equipment shed. That equipment radio then hands the signal back off to a combiner, which goes back up to the tower and then back out to the subscribers. Today, though, we're going to be focusing on the section in blue, subscribers back to your radio. So the first thing to understand about your receive system is that all receive systems are noise limited. There's a lot of noise that's out in the real world. This can be thermal noise, environmental noise. There's electronic and RF noise from other people's radios. And it's important to understand where all this noise is coming from. The goal is to make sure that the desired frequency gets through. But if it's too close to the noise floor, it'll be impossible for your system to hear it. So this is called the signal to noise ratio. And we want to keep that signal above the noise floor of everything else that's in the environment. Along with this other noise, we have some losses that happen in our system. The first is what's referred to as path loss. As your signals go through just free atmosphere, there's a certain reduction in signal strength. Every time the distance doubles, your signal is going to fall by about 6 dB, which is a quarter of the strength of what you originally transmitted it with. In addition to that, any sort of terrain or other obstructions can reduce the signal level arriving at the receive antenna. This means that things like mountains in the way, even heavily wooded areas, or even if you're in the middle of a city, you could have some losses due to those obstructions. The second thing that we've got is cable loss. Cables have a resistance that further degrades the signal. And for a 7/8 transmission cable, that's about 1 dB of loss for every 100 feet at 800 megahertz. So if your tower is 300 feet tall, you're going to have a 3 dB loss just in your cable. And that's about 50% of the power of the signal. Well, that's really not good for your system in general. So we have to overcome these losses. In addition to those, we also have insertion losses from passive components. Your antennas, your connectors, your jumpers, your filters all have insertion loss as part of them. They're all going to degrade your signal even just a little bit. We have to overcome that loss too. So these losses all add up. And every time you have a loss, your coverage is reduced. Your signal is getting closer to the noise floor and it's harder to hear it. This means that your subscribers have to be closer to your antenna in order to get their message through. Obviously, in large counties, that can be a problem. So how do we deal with all that? Well, one possible solution that some of you might be thinking of is that we could increase the transmit power. This would be okay if your radio was stationary and you had all sorts of power to pump through it, but it doesn't work very well for subscribers because they're limited by the output of their handheld radios. They don't have any extra amplifiers that they can pump their signal through. So we're going to use a different solution, better solution, of adding a tower top amplifier system. So what is the tower top amplifier and what are its uses? Well, the main thing is the tower top amplifier system is an amplifier mounted on top of the tower and a base control unit installed in the rack in the equipment shelter. Together, these two components will improve your coverage by minimizing the impact of loss. This is done by amplifying the signals as they're received at the antenna prior to it being further weakened by all of your cable losses. We recommend that you use a TTA anytime you have a cable loss higher than 1.5 dB. And this is pretty common in the 700, 800, and 900 megahertz frequencies. Some of these towers are quite tall. Their cables are going to be long. Use a TTA. It's important to remember, though, the TTA is going to amplify everything within its frequency range. So if there's another signal, we have to be aware of that. So let's take a look at what the system actually looks like. And here we've got a diagram showing all the different components. We have our receive antenna, and that hands off the signal to a tower top amplifier. And this is the box that we mentioned on top of the tower. Comes down through the line to the control unit, and the control unit then divides it up and hands off all of your signal to your radios. Radios hand it back to the combining system, back out through the TX antenna. Now, this control unit also has some internet Ethernet links to it. This means that it can send you alerts through the internet to either your desktop computer, your email, whatever system manager you're using, or even your cell phone if it has to. That means that you can monitor your equipment without ever even being on site. So going through the components, first we have the TTA box itself. And here we've got an example of the 432B model TTA box. This box has a filter inside of it. It's got an amplifier, and it's got some lightning suppression on it. The filter will control all the signals coming in, make sure that we get the window that we want. The amplifier boosts the signal strength, and the lightning suppression protects the TTA in case there's any inclement weather. The second portion is the control unit. And this control unit is about 1 to 2 rack units tall, and it's mounted in the equipment shelter. It also has an amplifier to overcome whatever splitters it has inside of itself. And it provides multiple outputs. Typically, we start with 8, but we can expand this all the way up to 32 outputs. So you can service 32 radios with one control unit. We also have optional pre-selectors that we can use to narrow the receiving frequency band. This is useful if you're in a crowded radio environment and you've got a lot of other people talking on the same frequencies that you are. Sometimes, though, we don't want to use a TTA. Usually this is the case when you've got a lot of line, or not very much line loss, I should say. In particular, if your antenna is fairly close to your equipment shelter. So instead of using a TTA, we're going to use what's called a receive multicoupler on this. The multicoupler is an amplifier and filter system for use with the receive systems. It allows one antenna to feed multiple radios, the same as the TTA does. And in fact, it's pretty equivalent to the bottom half of the TTA. The difference is that it doesn't have a tower-topped box on it. It does, however, have wider applications than the TTA does. So let's get into this RMC a little bit. RMCs can be used in VHF, UHF, 7, 8, or 900 megahertz systems. They're used for all systems and all ranges if needed. Again, we have multiple ports, so we can have one receive multicoupler providing up to 32 different outputs so that you can put as many radios on your system as you want. We can add further splitters, but each time we add a splitter, we're adding a loss inside of our system. So here we see a typical receive multicoupler system. Again, we have our RX antenna, and we're seeing that we're coming into a filter right here. This is referred to as a windowed system. This filter passes everything within its range. That filter then hands off through a sampler to the amplifier on the receive multicoupler. And that amplifier then hands off to the splitter and out to your radios. The incoming receive signals being filtered through this bandpass filter here is a good thing in that you can very narrowly select what signals you want. But when we're in a windowed system, everything within that window comes through. It's important to remember this, especially for VHF systems that have a very cluttered RF environment. As we mentioned before, we have RMCs that will cover all the frequency ranges: VHF, UHF, 7, 8, and 900. It's important, though, that these systems have a pre-selector, which is that bandpass filter in front of the system. The TTA system has this as part of the tower top box, but the receive multicoupler does not. This filter helps in two ways. First, it protects your system from powerful interference signals. Second, it only lets through that desired frequency range. Not using a bandpass filter in front of the multicoupler could actually cause damage both to the multicoupler and to your radios if somebody else has a particularly powerful signal. So what are some key features of this receive multicoupler? Well, the first thing is that we've got some redundant amplifiers in it. If one amplifier inside fails, there's a second amplifier. There's actually 4 amplifiers inside that will pick up the slack. Typically, we've got 15 dB of gain for 8-port models. Again, adding more ports means a little bit more loss, which means less gain overall. This gain is adjustable in 1 dB increments. We also have expansion kits for adding additional ports. We've got narrowing filters and pre-selectors that are available in whatever bandwidths you need. We've got an isolated front panel test port for unobtrusive measurements. That's that sampler that we mentioned earlier. It's got built-in current monitoring of the amplifier to make sure the amplifier is functioning properly. You can also add on power monitoring as an additional product. That'll be discussed in a separate presentation. Some systems, we mentioned earlier, a windowed frequency system will not work by itself. And this is particularly common in the VHF frequencies where there's a lot of clutter. The 7, 8, and 900 megahertz frequencies are fairly well structured, so it's not really a problem there. Either way, though, if we're in one of these cluttered environments, we might not be able to use just a simple window or bandpass filter. In these systems, we have to go with what's referred to as a channelized approach, where each individual channel is filtered and amplified separately. For this, we have to look at every transmit channel and every receive channel to determine what isolation is needed for each one. Obviously, this could get to be a lot of work. And here on the right side, we could see a channelized system, and this has 28 different filters on it. This is a huge system because of the frequency plan this particular customer had. Each channel needs its own amplifier to overcome the losses, and each amplifier can only handle one channel. So in addition to all these filters, you can see that we have a total of 6 amplifiers on this system. Each RMC deck can have up to 4 amplifiers on it. So if we're doing 6 amplifiers like the previous system, we would need 2 decks. These amplifiers can be any combination though of VHF or UHF, so that's great. It lets you add on as many frequencies as you need. Again, they're low noise amplifiers, they're quad coupled for redundancy, and we still have our 15 dB of gain adjustable in 1-step increments. Each amplifier has its own test port for proper setup and monitoring. Each amplifier operates independently of the other amplifiers on the deck. So what are some considerations when we're using receive multicouplers in your system? Well, the first that we mentioned earlier was congested areas with a lot of other high-level carriers coming into that receive passband. If you know that there's another high-level signal coming in, you might need to isolate for it. Your receive multicoupler will not do this on its own. So you're going to need some sort of signal selector of some kind. Filter is usually the easiest way. Second thing, in order to do that, you have to know what other signals are actually coming into your receiver. If you don't know what your environment is, you won't be able to block out those other signals. Of course, the more signals that are in your environment, the more filters and pre-selectors you're going to need to protect your system. This can be challenging physically if you have a fairly cluttered environment. As you saw before, that system that we were looking at was very massive. And that means that it takes up a lot of space in your equipment shelter. Not only that, but a lot of times the closest signal to your receive frequencies are actually your own transmit systems. So you need to make sure that you protect yourself from your own signals. Finally, there's also intermodulation products in the system because of multiple transmitters that can cause a potential interference. We'll talk about that in a few moments. We mentioned isolating your receive systems from your own transmitters. Easiest way to do that is with antenna isolation. This is to say, don't put the antennas near each other. If you can have some distance between your transmit and receive antennas, that buys you some isolation all by itself. Vertical separation is better than horizontal separation because in a vertical system, those 2 antennas are effectively in each other's blind spots, so you're not getting any interference off of the other antenna. In a horizontal situation, you're going to need a lot more space between your antennas. Now, intermodulation. This is something we mentioned before, and I said I would get back to it. Intermodulation is the result of mixing 2 or more signals in a nonlinear junction. Well, what does that mean? That means that you can mix them in an amplifier, in the receiver front end, in any place where you have dissimilar metals. This can be a connector, this can be a rusty bolt on your tower. Whatever the source of the intermodulation is, though, it's important that your receivers are protected from any intermodulation signal. This way you can still hear your receive frequencies without having them stepped on by any sort of other transmit or other carrier in the area. So let's recap this. We're going to have some quick key factors here. First, know your own system's transmit and receive frequencies and how they interact. You mentioned that you want to isolate everything and you want to protect your own receivers from intermodulation from your transmitters. Second, know your environment. Anytime you have a high-level interference signal or a lot of noise in your environment, that can cause a problem for your receivers, and you have to overcome that. To help with this, though, TXRX offers spectrum fingerprinting and noise floor monitoring as a service. This is a 24-hour monitoring period where we will come to your site, set up some monitoring equipment, and listen to what's going on in the environment for a full 24 hours. At the end of that time, you'll get a report saying what high-level carriers are in your area, what you need to isolate for, whether or not you can just use a basic windowed system or if you need something a little bit more complex. If you work with experts such as TXRX, we can definitely help you define your needs and get you the optimum balance of system specs, size, cost, and make sure that your receive signals are properly protected. To help with this, we actually have a requirement specification document that's on our website. There's more information that you can provide. The more accurate your design or quote will be, and the better system that you're going to get. To show you how to get to that, let us go to that website for just 1 second. Unfortunately, I can't get to that. We'll get to that in just a moment. That will be available on the TXRX website, txrx.com. On the right side, there's a link that says contact. When you hit that link, the requirement spec document will be there. There'll be a link to that. Just hit that link too, and you'll be able to see that presentation or that document there. So why are we going to choose TXRX over someone else? Well, the first thing is that we're the industry leader in this. We have a history of providing superior products and services. We were founded in 1976. We own the patents for combiners and TTAs. And we've been a preferred supplier for some major OEMs for 30 years. Second, we have a dedicated applications engineer to customize your system. We have proprietary design software to get you a fast quote that's accurate to what you need. And we can mix and match different filters for optimal performance to get you exactly what you want. Finally, we've got a record of quality, reliability, and prompt delivery. We're ISO 9001 certified, that's 9001 2015. We have less than a 0.1% warranty return rate. Typically, we can ship in 4 to 5 weeks from when you put in your order. We're 97% on time to that goal. One last recap. The receive portion is the hearing portion of your system, while it transmits the speech portion. Either the transmit signals themselves or their byproducts can overwhelm your quiet receive signals. Your receive system is all about improving the sensitivity. This will help with your network coverage and will help to expand the range of your receive system. It's important to monitor your receive signal levels and receive antennas. Make sure that you don't have any high-level carriers or intermodulation problems. Understand these design principles. Be aware of the risks. Proceed with caution. Don't be afraid to ask. We're ready to help you. Finally, we have some contact information. As I mentioned earlier, we have a website, txrx.com. We have some dedicated mailboxes for timely response. First is sales@txrx.com, and the second is customer service at txrx.com. Sales will be for all new sales. Customer service will be for anything post-sale related, such as warranty or repair requests. Retunes for your system are also handled through the customer service desk. In addition, we have some key personnel. First is Mike Ryan, director of our sales and marketing group. Second, we have Scott Galligan, who's the inside sales manager. And finally, we have myself, quality engineer for any of warranty or repair issues. And that will end our presentation. So let's get into these questions.
Jason, thank you. I believe you can see the questions, but I'll go ahead and read them off just to make sure everybody can see and hear them. First one is, will you talk to the use of a TTA or not, using one at UHF and VHF?
Sure. First, our TTAs are typically for the 7, 8, and 900 megahertz frequencies. We do not offer a TTA in VHF or UHF. And the reason is because of the complexity of the signal at that point. The TTA is designed for a windowed system, and the VHF and UHF frequencies are highly cluttered, so we cannot just use a windowed system in those ranges, at least not reliably.
And I could add some to that. With VHF and UHF, the noise floor is often quite high, and the TTA will amplify the received signals, but it will also amplify the noise. So a high noise floor that is amplified can often negate the positive effects of the amplification of the received signal. We used to have a UHF TTA, but it was discontinued several years ago due to lack of demand. And then one of the other questions is, what is the range improvement from using TTA at 800 megahertz?
Well, this is a bit of a loaded question because there's a lot of environmental things that need to be considered. Your TTA will generally provide 15 to 20 dB of gain, but how much actual range that is depends on what your environment is. If your environment is in the middle of Iowa where you've got nice flat farm fields, you'll get a lot of range. If your environment is the Rocky Mountains or the middle of Los Angeles, you won't get nearly as much range out of it.
Okay, thank you. Another question here, can you talk a little more about the test port neg30 on the multicoupler?
For that one, I'm actually going to hand this off to Jim Grotke. Jim is one of our applications engineers. Jim, can you give us a rundown of what this test port is?
Hi, yeah, that's basically just where you can take a sample of your signal 30 dB down so you can see what the signal is doing without having to shut your equipment off. Basically it.
Okay, thank you, Jim. And are there any more questions? We'll give it, I'll give it just a bit more time to see if anyone else wants to ask another question.
I'm going to see if I can find that questionnaire again. I didn't have a chance to get there, so let me see. Aha, I found it. So I mentioned the questionnaire earlier. This is our homepage at txrx.com. Contact button is in the upper right. You hit that button, it takes you to the contact page. On the contact page, under email, sales or related inquiries, there is a request for quote requirement spec. So let's go to that. And that opens this Excel spreadsheet that you've got. You can fill in all of your information, your channel names, your frequencies, as much information as you can get to us. The more information, the better. You can never give us too much information on this.
All right, well, thank you, Jason. Thank you, Jim. We do not have any more questions coming in, so I'll end the webinar now. I will send everybody a link to this webinar, but thank you for your time today, your participation. Feel free to contact us if you have any more questions or comments, and enjoy the rest of the day. Thank you.